Okay, well, I won't delay anything anymore. Our speaker tonight comes to us from Fort Wayne. I had it wrong earlier. Eric Potter. I won't, I have stolen people's introductions, so I will let you introduce yourself there, but give him a round of applause.
All right, so tonight we're going to be talking about Project Roslyn and how that can benefit you as developers. How many of you guys are familiar with Roslyn? If I say, we're going to talk about Roslyn, you guys know what I'm going to say? For the uninitiated, Roslyn is Microsoft's next generation C# and VB compilers, which on the face of it isn't terribly interesting because requirement number one for the new compilers was that they do exactly what the old compilers did. Right? And we've had a C# compiler for as long as we've had C#. So to say we have a new compiler, that's not terribly interesting. But what's interesting is that we now have new ways to use the compiler. Of course, we're going to use the compiler to actually generate our executables, but we can now get in the internals of it, see what it's doing, get information that it has, use it in new and interesting ways. So that's what we're going to be talking about tonight. Like Rob said, from Fort Wayne, I work for a great little software company called Aptera. My boss likes to say it's a company with a Midwest work ethic and a West Coast feel, as evidenced by me being interrupted in the middle of one of my Pomodoros today by a Nerf dart hitting me in the head. That's all right. I've been developing software for about 15 years. And as a side gig, I teach as an adjunct professor at Indiana Tech. I say that because that's actually where I started using Project Roslyn. Roslyn has been around as a beta for 3 or 4 years now. And one of the things I was able to do with my sophomore and junior level students is have them use the Roslyn API to analyze C#. And I was teaching a object-oriented design class, and so I would give them assignments to take a C# file as input, and we would do some really rudimentary metrics to analyze how object-oriented their code was. So they could do things like count how many methods are in a class. And this is something that students often have a challenge with when they're first learning OO, is they think they have a class that they have one 300-line method that is object-oriented. Or, if they have things that are nested 30 levels deep, that it's somehow better. And so we would do some things like that to see how encapsulated their code was and how decoupled their code was. And that's actually where I've spent a lot of my time in Roslyn. And I just say that to point out that it is something that is pretty approachable, because these were still students. Some of them were pretty good coders, some of them not so much. One of the fun things about those projects is that some of the students would do the project and they would do it the right way. And it would get to work and the code would be well structured. Some of the students would not get it to work. And some of the students would get it to work, but their code would be a mess. And so when they would do this, what was fun was to take the source files for their application and have their application analyze itself. And so you could do things like have their application analyze itself. And like, look, your code is telling you that you have this too tightly coupled. Okay, well, what does that mean? Your code knows it's bad. It's trying to tell you something about itself. So that's where the title of this talk is C# Inception, because there's a lot of those moments where you're kind of going deeper and deeper down the rabbit hole like that. Back to my bio. I have a wife and 5 kids. They're fantastic. My oldest child is 11, and he just started writing code, and I could not be prouder. Even if they're primarily Minecraft plugins. I tried to get him interested in code a couple other times, and then I saw all my kids are super obsessed with Minecraft. And so I got this book called Teach Your Kids How to Program with Minecraft. And my wife had opened it when it came in the mail and had set it on the counter. And by the time I got home from work, my 11-year-old was like 5 pages in already. He just picked it up and started reading it. Dad, can we make these cows explode? Yes. Cool. What's Java? I never thought you'd ask. You can follow me on Twitter at PotterEric. Having the last name Potter means that any name on the internet you want to get is up. So, PotterEric. I blog at HumbleToolsmith.com. I do have a blog post I'm working on about some of this Roslyn stuff that we talked about tonight. It's just not quite finished yet. So that'll be up there soon. And then I'm a Microsoft MVP for .NET. So like I said, Roslyn is the compiler, but it's bigger than that. It is the ability to know what the compiler is doing and have tools around that. So this is a flow diagram for almost every compiler you've ever used. Whether you know it or not, this is how they're structured. And if you had a compilers class in college, this will probably look very familiar to you. You have this black box for C#, that's probably been Visual Studio for most of us. And that was actually using an executable that was on your machine somewhere called csc.exe. And you would have code, and it would go in one side of the black box, and an executable would come out the other. Technically, it was a IO assembly, but we can think of it as an executable. And inside that black box, it would do some parsing. It would parse out the symbols. It would bind up all the symbols, and then finally emit some kind of executable. That worked well. Every C# application I've ever written used this, and it worked fine. There were some times when I thought that there was a problem somewhere inside this compiler because my code must have been right and the compiler was clearly wrong. In each one of those cases, the problem was certainly between the chair and keyboard. I have found a way to, we call those pep cactors, right? The problem is between chair and keyboard. I have finally found a way to eliminate all pep cactors. I have a standing desk. There's no chair. Can't say that. So now for me, it's like problems between floor mat and keyboard. So this is Roslyn. Roslyn has the compiler that we've always had before, but now we have APIs at every step along the way. So when the parsing phase is finished, we have a syntax tree API. This means that we can actually get in code the abstract syntax tree that is the compiler generated for our code. And it's not just some representative abstract syntax tree, it is the abstract syntax tree. And so that allows us to do some really powerful analysis fairly simply. Beyond that, after the symbols are resolved, we can get an API to the symbols. After the binding is done, we can do things like look at the flow. We actually even have an emit API that allows us to alter what is being produced by the compiler. I will say this, there is a huge surface area to Roslyn, and tonight we're mostly going to focus on these two parts of the API. If we were going to cover all the parts of the API, we'd be here till the Cubs won the World Series. right now, Roslyn supports two languages, C# and VB. There's talk about having more languages in the future, but right now it's just those two. One of the fun things about that is the C# compiler is now written in C#. So here's our Inception moment number 2. You can download the source code for Project Roslyn, look at it, compile it, and then it can compile itself. I have a fun stress toy for whoever can tell me what language the current C# compiler is written in. Yeah, so it's one of those problems where you can't write a C# compiler until you have some C# compiler, right? And so the original version is written in C++. That has meant for most of the last 15 years, the guys that were developing the language they wrote in was C++. So it's kind of a fun challenge. When I say fun, I mean not fun. And I think one of the reasons why you see the theme of the new features in C# being these minor improvements is because all those guys had to write C# for a living for the last year and a half. So that's why we're now in the new version of C# getting the property initializers. That's not a like mind-blowing, world-changing feature, but it's certainly something that's nice to have. And so I think one of the side benefits of having Project Roslyn is the language will get better for us because of that. I have another one of these. If anyone can tell me what is the first Microsoft language to be able to compile itself? Not assembly. No, not basic. Guess I'm keeping it. It was F#. F# has always been able to compile itself. And part of that is because in the beginning, F# came out of OCaml.net. And so OCaml.net was originally written on OCaml. So since the time there was an F# that compiled itself. When they first announced Roslyn, they referred to it as a compiler as a service. And they got away from this terminology because people got confused with the idea that the compiler would be in the cloud. Which Microsoft does have that, right? They have Visual Studio Online where you can, in Monaco, you can go in and do all your code editing right online. But that's something different. When we say Roslyn is compiler as a service, what we mean is that it's like a local service running on your machine. It is an executable that you can call into, that you can manipulate, you can get it at state, you can access its behavior. So that's what we mean with that. One of the other fun things with Roslyn is that it is used in some other tools that you may be familiar with. How many of you guys are familiar with Script CS? Nobody? All right. So Script CS is this tool that allows us to write C# in a read-eval printer. If you guys have spent any time doing Node, or if you've spent any time writing Python or Ruby code, you'll know this is a really common way to work, where I just want to be able to drop into the command line and test out some code. So I can say Script CS. I can say var a equals 3 plus 7. And if I output a, I can see that I got 10. This is kind of a trivial example, but we could do something more interesting, like say var now equals now. And so you can see that I could get more interesting examples out of this. But what's interesting about this from a Roslyn perspective is what happened when I typed var A equals 3 plus 7. Script.cs did the work that it took to take what I typed in and actually jam that into a C# program and compile it. So we're in this command line environment, but we're actually working with C# code. And you can find examples online of people hosting web APIs right in Script.cs. I think Script.cs is just a nice way to test out little snippets of code. So there's a lot of nuanced things about string.format, for example, that I always have a hard time remembering. So I know that if I want to right align something in 20 spaces, I could do that. If I want to specify a number of decimal places, I could do that. But if I need to do both, it's hard to remember which order they go in. So if I say var pi equals 22 over 7, what will I get for the value of pi here? I'm seeing it back here. Why am I getting 3?
Because you had 2 integers and you divided it.
Remember, this is valid C# code. So if I have integers, I'm going to use integer arithmetic. If I had done var p equals 22.0 over 7, then I would get the number of things. So all this to say that some guys went out and used the Roslyn compiler and tied it in with this command line environment so that we have a new and interesting way to compile C# code. It can be a nice way to go out and try little bits of C#. One of the guys on the Script.cs team was joking around and he said, most C# developers I know have about 30 folders on their machine, like console application 1, console application 2, console application 27. Because there's always those times you just need to test out what happens when I say datetime.format and I pass in Brazilian. And so it's nice to be able to test out those cases in Script.cs. Roslyn is also used in the new version of ASP.NET. If you've read much about this, you know that in the new version of ASP.NET, we have the ability to have code auto-compiled. So I make a change in the code, and I go to the browser, and I hit refresh the page, and I have the new version of the code. Roslyn is used in the background to be continuously compiling my code, so I don't have to have that declarative compile step. I just go to the browser and everything's recompiled. One of the really big announcements about Roslyn is it's now totally open source. So if you go out to github.com, .net/Roslyn, you can actually download the source. There's a lot of it, but it's kind of fun to see. And it's kind of neat to see the type of C# code that the guys that author the language write. It's kind of interesting. They have taken some pull requests from the community. Obviously, no changes to the language, but they are doing it in a very open manner. And they also have been putting their design notes for the next version of the language up on GitHub. So if you want to see the features they're talking about down the road, those documents are up there too. One of the interesting possibilities with this is that you could actually go in and alter the compiler and change something about the language. And one of the big big announcements, Anders Halsberg, who's the primary architect of C#, while he was on stage, changed the language so that French quotes were a valid way to quote strings. Something else that you could do, and there's some other languages that have some kind of neat features. The Elixir language, for example, has a keyword called unless, which unless is basically if not. You know, kind of neat. So if you really wanted to have the unless keyword in C#, you could get in there and do that. Now it's probably a terrible idea to do for production code. It seems like a really bad idea to have production code that had a dependency on a compiler that you specifically put on. That just screams like somehow you lose all the source of that compiler and you have to maintain that code for 30 years. But you totally could do that.
He says, ha-ha.
There's a guy up in Chicago named Joe Hummel. He teaches at one of the big universities there. I can't remember which one. But he's done some stuff with his PhD students where they've actually altered the language and done interesting research on it. Probably not practical for most line of business tasks. Could be fun. So, like I said, there is a very large API. We looked at this, we already talked about this part of the compiler pipeline already. But there are other parts of the API as well. So in addition to the compilation API, there's the workspace API. And that gives us the ability to work with solutions or projects or documents. And so this would allow us to do things like custom code formatting. We will have access to the final references functionality. And one of the things that Microsoft has committed to is not having any secret backdoors that Visual Studio uses that you don't have access to. So if you use the Roslyn API to final references, you're using the same code that Visual Studio is using. And then lastly, there are the feature APIs where you can have custom refactorings or custom code fixes. We'll talk about these more later. The other thing I wanted to mention on this slide is that only the feature APIs are dependent on Visual Studio. So if you want to have a custom code fix, that has to execute in the Visual Studio environment. All the rest of these could be done completely independent of Visual Studio. So if you wanted to write some kind of analyzer, like if you just wanted to count how many methods were in a given class, you could write a little console app to do that, or you could write a WPF app to do that.
Why doesn't it have to be able to do that?
That will become really clear later. Ask me that near the end of the presentation if I don't, if it's not up to that. So let's say you want to play with the Roslyn API. There are a couple ways you can do this. Certainly the easiest one is to go out and get Visual Studio 2015. So tonight you could download release candidate, or you could wait like 10 days and you could get the real one. And if you have Visual Studio 2015, you can go out and install Visual Studio 2015 SDK. And that will give you some new project options to create a Visual Studio application or create a diagnostic code fix. The other way that you could do this is just to go out to NuGet and pull in the Microsoft.code analysis packages. I put Microsoft.code analysis **. They have a handful of packages. So if you just wanted to get the C# DLLs, you could do that. Or if you just wanted to get the VB one, you could do that. If you want to have them all, there's packages. So if you just wanted to start playing around with what Roslyn can do, that's the simplest way, is just to pull a NuGet package. And those NuGet packages are provided directly from Microsoft. So let's auger in a little bit more into the API. The things that I'm most interested in are analyzing code, visualizing code, and refactoring code. At Aptera, we are contractors, and so a lot of times that means we get to work with code that we didn't write. Sometimes it's code we have never written. Sometimes it's code I don't know why anyone ever wrote it. And so, what fascinates me about this is the ability to write tools to help me understand a code base faster. So I want to be able to write tools that generate some kind of summary of what's going on in this code, or be able to tell me what are the methods that are being called all over the place. So what are the methods that are really big and complex? Because that's probably where the interesting things happen. If you don't remember anything else from what I say tonight, this is what I want you to take away. In the same way that unit tests allow us to test code with code, Roslyn allows us to understand code with code. One of my core competencies, which is writing code, to test code, right? And that allows me to use my core competency to make my code of higher quality. And so if I can use my coding skills to help me understand code faster, that makes me more productive. So as we get started with Roslyn, the most important technical aspect you need to understand is the Roslyn abstract syntax tree, which is generally like the abstract syntax tree for any other language or any other compiler architecture. It's a very common data structure. The syntax tree is a tree structure like from your CS curriculum. And it's made up of 3 types of nodes. There are syntax nodes, which are the bulk of the nodes in there. These are the nodes in the tree that represent method definitions, or if statements, or properties. And then there are syntax tokens, which these are more of like the leaf nodes of the tree. These are more of the atomic elements, things like curly braces and semicolons, or individual words. And lastly, there are syntax trivia. And the syntax trivia are basically the comments in the white space. And the reason that the trivia nodes are in the tree is that one of the things we want to be able to do with Roslyn is to be able to write custom refactorings. And if I'm pulling a method out or pulling a block out and putting it somewhere else, I want my comments to come with it, and I want the formatting to roughly be there the way it was before. So all that trivia is in the tree. So let's look at some code, how we get the abstract syntax tree. So I've got a fairly straightforward application here. And we're actually going to do some analysis of a file called Euler9.cs that has nothing very special about it. In fact, the method names aren't even that good. It happens to be a solution to problem number 9 on projecteuler.com. But there's a good projecteuler.com. But what I want to show you is that this file has a handful of methods: main, binary search solution.
Good note.
Good question. How about this? I can't very easily because this is good. But
Windows Plus should be magnifier, I believe.
So, nothing terribly exciting about this file, but there are some methods there. And we can see that there are. How to get out of it.
Windows minus.
So So here's my Roslyn code, and this I wrote, it's just a console application, and I pulled in the NuGet packages to give us Microsoft.code analysis and Microsoft.code analysis.C#, and on and on. And the Visual Basic ones happen to be in here, so I'm not using them in this demo. But here's all it takes to get the syntax tree. I'm going to say, I'm hard coding the file name, and I'm going to read in the file as text. And I'm going to call this static method on the C# syntax tree named parseText and pass in the contents of the file. This is actually calling, this is the first step in the compilation process. This does the parsing. So this tree variable has a type of syntax tree, and it really represents the entire abstract syntax tree. And so I can get the root node of the tree, and from there I can start to ask it interesting questions. Like I want to get the descendant nodes of type class declaration syntax. That was the first one. And then I want to just write out the identifier for the first class. So that would be program, because that's the class name. One of the nice things about the abstract syntax tree is that it does support iQueryable, and so you have all these nice, all your link methods work kind of the way you would expect them to. And they've done a nice job with the methods inside, so you can do things really easily, like say, I want to get all the descendant nodes of type class declaration syntax. So without having to do any of my own parsing, I now have the first class. And if I want to get the names of all the methods, I can just say first class, descendant nodes of type method declaration syntax, and I'll just convert it to a list, so I can say for each, and then just write the identifier to the console. So with 40 odd lines of code, I now have, there we go. So I have the application closing on read key, and every time I get Windows Plus, so you have to take my word for it. It's printing out the.
You just deselect the Windows so you can Windows Plus. Or put a breakpoint.
So you can see it's printing out program, and then which is the class identifier, and the method names, which are main, binary search solution, find the right ID, brute force solution, and is Pythagorean triplet.
Does it just throw an exception if it doesn't file?
Fantastic question. So let's put some compile there. So keep in mind, let's say this is Visual Studio 2015. This is entirely true. If this were Visual Studio 2015, this would be Roslyn that's generating the compilation errors. And because I have a syntax error here, it's giving me the diagnostic, which is the fancy term for what I call red squigglies. But it didn't, the compiler didn't bail out. And we can see that there's actually another one down here. So what actually happens is if you have compilation errors, it doesn't throw an exception. It returns an abstract syntax tree that has error nodes. Or sometimes it will have this, I think the way that this works is it has a node, or it has a syntax trivia node, and it has a property on it that says is missing equals true. let's look at that. Let's dig in to that example. So there is a tool, and this is a plugin you can get for Visual Studio 2015. So I just switched over to Visual Studio 2015. And let's say that I get rid of that semicolon. I have what I'm seeing in this view is a representation of the syntax tree. So you can see my root is this compilation unit, and then there's all these using directives. And then there's a namespace declaration. And my namespace declaration has a class declaration, which contains property declarations. And this method declaration has a block, and the return statement has a semicolon token. And you can see the semicolon token has a property of is missing set to true. So there are times when the compiler will bail out because it gets so confused. But it will try to, it will soldier on as long as it can, so it can give you as many of the errors as it can. So, no, I don't believe it ever throws an exception. It returns an abstract syntax tree with error names in it. So when we're talking about the abstract syntax tree, all the nodes in the tree inherit from an abstract class called syntax node, and all the C# syntax nodes inherit from a class unsurprisingly named C# syntax node. And from there, they start to break down. So we have statement syntaxes and member declaration syntaxes. And so where a method is defined, we're going to have an object whose type is method declaration syntax. If it's a constructor, it will actually be a constructor declaration syntax. When we get into statements, there's classes for if statements and switch statements and for statements. So every node in the syntax tree is strongly typed, and it is, gives us interesting information about that. And we can write our queries against it pretty easily because the names are very discoverable. Now, one of the things that's big in the new version of Visual Studio is this project type called diagnostics and code fixes. And this is probably where you'll see the most custom development with Roslyn. A diagnostic is what Visual Studio refers to as the squigglies, right? So if I have an error diagnostic, it's going to show me a red squiggly. And then I can also have diagnostics that return information or warnings. And I can also create code fixes. A code fix is what I get when there's some error, and Visual Studio knows that there's probably a way to fix it. So if I were to comment out all my using statements, I would get a lot of diagnostics all over the place telling me that the language names does not exist in the current context. That's a diagnostic. If I hit Control Dot, or if I click on the light bulb, I will get a whole slew of potential code fixes. So I could say, I could just add a using for Microsoft code analysis, or I could change the name to language names, Microsoft code analysis language names. So these terms, diagnostics and code fixes, what they are is going to be very familiar to you. You might not have heard the terms before. There we go. So we're now allowed to write our own diagnostics using Roslyn. And so the first one I show you is one of my pet peeves with some of my younger coworkers who like to name their variables and methods food. So what I want is a custom diagnostic that will fight food. So let's look at what it would take to do that. So if we come into Visual Studio 2015, and I actually have the Visual Studio 2015 SDK installed. When I say, if I say new project, I have under, let's see, extensive code. Yeah, there it is. I have some new templates for standalone code analysis tool, which would basically create a console application with the Microsoft code analysis DLLs already pulled in. I could create an analyzer with code fix. That's the one we're going to look at. I could also create a code refactoring, which would add something to the refactoring menu in Visual Studio. I've already created this analyzer, so I'm not going to create a new solution, but that's pretty much what I did. So let's look at what this does, and then we'll look at how it does it. So this template actually creates a v6. There's this DaveGirlAnalyzer.v6, which, if you're not familiar with that, is basically the file format for Visual Studio plugins. So I could compile this and distribute this to my teammates, or I could install it on my build server, or I could put it up on Visual Studio Gallery. This particular one probably not going to make it up on Visual Studio Gallery, but your diagnostics would be much more useful when you do that. So what happens when you have a diagnostic, like when you have any V6 project, is that you hit debug, and it'll actually launch another version of Visual Studio, which is fun. And when it launches this next version of Visual Studio, it will have my V6 already installed. So I'll launch the project called My First Program. And you can see that I have a method named foo. And when I hover over that, I'm getting a helpful warning. Hey dummy, don't use foo as a variable. And I'm also getting a light bulb telling me that there's going to be a way to fix this. So I can click on that. Ooh. Apparently I encountered an error and then disabled. That's not good for demos.
Copy your own template. Dave Grohl copy it.
All right, well,
It'd be great if the error, you make a custom error message. Dave Grohl analyzes long, Dave broken flag.
that would be
So the fun thing about this is that it didn't take a lot of code to do this. And a lot of the code you're seeing here is actually boilerplate. Like this existed when I created the project, right? So I've got my diagnostic ID, it has to be unique. I've got a title and message format, and some other boilerplate text. And I've got some boilerplate code to have a diagnostics collection. But what's really the most important part of this is that in my overridden initialize method, there is this method on the context called register symbol action. And what that means is that every time the compiler encounters a symbol of type method or kind method, I want to call back to my analyze method. So this is, someone had asked me why diagnostics and refactorings had to be in Visual Studio. It's because they don't run the compilation process themselves, they tie into the compilation process that Visual Studio is already running. So once I have my analyze method, then every time a symbol is encountered, I can say, I can get that symbol, and because I know it's a method, I'm going to cast it to an iMethod symbol. And I can say if the symbol name is foo, I'm going to create a rule, and I'm going to report that diagnostic. Now, for the squiggly to show up in the right place, I'm going to pass in the location of the symbol, the offending symbol. And I'm also going to pass in this rule definition, which is defined up here. And you can see that I had made this diagnostic severity a warning. But if I wanted to make this an error, I could have just as easily made it an error. So that works out pretty well. Now the part that is apparently not going to work, that's kind of disappointing, is that we can also have a code fix. And so this is the code fix that I'm going to register with that diagnostic. And here's the code, and again, a lot of this is just template code. So I can actually provide a code fix for the error. And when the code fix gets run, it's going to find that identifier token and replace it with a new name, which is Fanny Dorf Jangle Plate, which is a terrible variable name, but slightly better than food.
Isn't it also an illegal symbol name because it's based on it?
It is. I really want. There's no way that I'm going to find out in a reasonable amount of time why that's failing, which is disappointing. What I want to show you is that when you run the code fix, it will give you a preview, and it's an illegal identifier, and it would actually show you in the preview that there's a compile error, which is pretty slick, right? Because I can say, I could run this code fix, but this code fix is actually going to create another error. And that, where it's really useful is actually for things like, I want to change the name of this to something else, but that name is used somewhere else so that I have an ambiguous reference. So it's actually really interesting. One of the other things that's worth noting about this is that I'm actually not altering the abstract syntax tree. The abstract syntax tree is immutable. So what I'm going to do is I'm going to run this method called rename symbol async that will return a new abstract syntax tree with my changes. Now this code just has that name hard-coded, but the name actually comes from the Benedict Cumberbatch funny name generator. And what we could do hard time. What we could do is actually call out to Benedict Cumberbatch codenamegenerator.com and screen scrape the name, because we've never used that site. You know, it generates a new name for every time. You probably don't want to do that in this situation, because keep in mind, the way the diagnostics work is we register for symbol text method, and so every time the compiler encounters a method, it calls our code. And so if we had a web service call for every time it encountered a method, that would be really slow. And so we wouldn't want to do that. So when you're creating these diagnostics, you do have to keep those performance characteristics in mind. Yes?
Could you generate a bunch of them manually and then put it in a array and then have randomly grab one?
You could, or you could read Bob Martin's book, Clean Code, and learn how to name methods yourself. That would actually, maybe that's what I should change the diagnostic to have a link to his book on Amazon.
It's literally the text that it replaces.
There's a lot of fun possibilities. So, I start with the silly one because it's easy to understand and it makes for a good example. But there are a lot of very useful things you could do here. One of the examples that I've seen thrown out a lot is catching the case where you have code and there's a try-catch block and the catch is empty. That's totally valid C# code. It's also totally a bad idea. And then I suppose there are cases when you just want to eat exceptions. In general, you should probably at least log it, if not throw it, right? And so you could create a diagnostic that registered for symbol kind catch. And you could get the catch, and the catch syntax node will have a block property. And if the block property has 0 children, then you could raise a warning or an error if you wanted to. And then you could also create a code fix that just inserted a throw in there. And so what you could do is really easily have ways to fix that code. This presents a lot of interesting possibilities for things that are specific to your team. Right? We have tools like fxcop and resharper that catch these broad categories of errors. But a lot of times we know, we have specific rules. There's something about our code base that we need to enforce. Maybe you need to always have, you don't want to have parameterless constructors because you want to make sure you have dependency injection, right? You could make it a compiler warning to have a parameterless constructor. What?
I still think you want to be able to deserialize.
Right, but it's one of those things where I
get the idea.
Yeah.
I was just kidding.
And maybe the flip side is true, right? Maybe you want to write a diagnostic that's an error if the class doesn't have a parameterless constructor, right? And that way, instead of getting the errors when you are running the code, you would get the errors in compile time, or warnings, or whatever you want. The last example that I'll show is actually one that I was doing this presentation over in Columbus, and some guy, it was at a conference called SurTrek, and over lunch, some guy asked me, he's like, hey, what I really want to know, I want to be able to find when my teammates write case statements, but they don't have a default. And there was something about his code base that made this a bigger problem. He goes, could you do that? I'm like, oh yeah, we could probably do that over lunch. And so we wrote this code fix provider that will find case statements without defaults. And we were able to put this together really quick, actually. And it's very similar to the last one. It's a little less silly. have my title, message format, all those things. But again, the interesting method is this time I want to register a syntax node action for switch statements. That means that this method, the method that I pass in, analyze switch statement with enum, gets called. And actually, that one of his things, he only wanted the error to happen when it was a switch statement that was switching on an enum. And so again, we have some code, there's a few lines, but it does everything he needs. So we're casting the node as a switch statement, and then we're looking at the variable type. So we're going to say switch statement node semantic model get type of switch variable identifier. Now, one little digression about the semantic model. When we call into the semantic model, we're now actually moving one step further in the compilation process. So before we were only worried about the syntax tree. The syntax tree shows the structure of the file. The semantic model now gives us meanings to things. So it's one thing to know that there is a line of code that calls a function. Like I can have a function invocation syntax. I can see that. But I don't necessarily know what method it calls. When I call into the semantic model, I'm actually going to move further in the compilation process where it's now resolving symbols. So this might mean it's going out to other files to find that symbol, or maybe it means that there's a method that's overloaded and it needs to go through the overload resolution rules to figure out which method is going to be called. So when I call in the semantic model, I can get more information about the type. And in this case, I'm going to get the switch variable type. And off of the type, I can look to see if the type is enum. And then to find out if the switch statement has a default case, I can just say switch statement descendant nodes of type default switch label syntax. And so then I have this statement more say if not has default and it is enum, create this diagnostic rule that is basically going to report this. So if I run this, I'll launch Visual Studio again. Here's my switch statement. In this case, I'm switching on an int. And so it doesn't have a default, but it's not an error. In this case, I'm switching on this enum, and I don't have a default, and so I'm getting this green diagnostic. If I were to comment this out, then the diagnostic would go away. And if I go back to the comment, the diagnostic comes back right away. Now, if we were to set a breakpoint, in here, and if I were to change this code again, what?
So that's awesome.
You'll see that here it's getting called once, and then I'll hit F5, and it's getting called again. And the reason it's being called twice, apparently it's actually being called four times, I'm not sure why. But it's being called once for each switch statement, which there are two. Try this one. So, close out this.
I'm not necessarily, how did you attach the debugger to the extension you have?
So that's the magic of having a V6 solution. So I created a new project, and the project template was diagnostic with code fix, which is what gave me this V6. And it's already set up. But if we were to look at the debug statements, it's going to start an external program, which is another version of Visual Studio, and it's going to pass in this command line argument. So
The template out of that? Okay, cool.
Then you just open the solution with the new one and test your.
yeah, the only thing you have to make sure is that the V6 is set as your startup project. All your code goes in the portable class library, but the V6 is the one you actually want to launch. Yeah. So one of the things that I have been asked before is why I'm so excited about Roslyn. And it's a fair question because, you know, when you first run Visual Studio 2015, there's not going to be any one thing that makes you say, oh, this has got Roslyn, this is so amazing. What's cool about it is what we're going to be able to build, right? The tools that you can build, the tools that I can build, we can create these diagnostics for each other. We can create refactorings for each other. Most of our time professionally is spent building tools for other people. Roslyn is one of those neat areas where we can build tools for ourselves. So I'm really excited over the next year, 2 years, 3 years, to see what people write, what gets put out there. I really think it's one of those things that's going to make our job easier. So, very excited about it. Any questions? Yeah.
I've got a couple here. What's the performance? Maybe this is. I have a feeling I know the answer possibly, but what's the performance on this versus say something like reflection? Like some of the stuff, the lower end of this is it within striking range of some of the stuff reflection can do. If you were doing say a large amount of reflection, would it make more sense to pay the penalty up front to run with the compiler and then have the ASP there to navigate?
So they kind of scratched two different itches. Reflection is still nice for things you can do where, like I want to invoke a method that dynamically, right? Like that's still something you do with reflection. But in terms of like generating code dynamically, you would probably not use Roslyn for some of that. If you wanted to have some scripting right in one of your applications, you could use the scripting API that ScriptCS uses to actually kind of generate, compile, and execute code right there.
So you no longer have to do this. I've seen examples of it in it's like IL and stuff like that. You can actually write it in something friendlier or generate it from structures instead of having to do that awful mess.
If you're going to do it today, you would definitely use the Roslyn scripting.
Okay. What's a good resource for documentation? Like, there seems like there's a lot of the position surface of it. Obviously there's MSPN is that.
I think the best, my favorite place to go is actually the GitHub repo. So github.com/.net/Roslyn. And if you go there, they have a collection of links to a lot of stuff back on MSPN. And so the GitHub repo is a good place to start. And they have entire documents about how to understand the abstract syntax tree, how to navigate the semantic model.
The V6s generate work in older versions of Visual Studio?
I don't believe so. And the main reason for that is the old versions of Visual Studio don't use Roslyn as a compiler. They're using CSC.exe as a compiler. And so the events that they tie into are 2015 specific. Yeah.
How did plugins like ReSharper do these kind of things before Roslyn?
So ReSharper and CodeRush and the other tools have all traditionally had their own parser. So one of the reasons that, I mean, ReSharper is a wonderful tool and super powerful. But if you're on a older laptop, it'll make it cry, right? I mean, ReSharper will slow your Visual Studio down to an almost unbearable level. And part of the reason you're doing that is every time you make a change, you're actually compiling the code twice, right? You're compiling it once for Visual Studio and you're compiling it once for ReSharper. So the tool vendors have all now, at least for 2015, made a decision about are they going to use Roslyn or not. So I think CodeRush is actually going to use the Roslyn abstract syntax tree for their parsing. ReSharper has said that they have enough magic goo in their parser that they're going to stick with it. Which kind of makes sense. I mean, ReSharper has spent years and years building up proprietary knowledge about how to do these things. So it'd be interesting to see over time if they move to Roslyn, but not right now.
Nothing that stops you from doing a piece deal.
Right.
It looks like this is something that you could slowly weave into a code base. I have no idea what their code base looks like, but I can see them being able to pack in bits and pieces of this for these features and slowly rewrite.
How did you first learn to use Roslyn? What were your resources to get started with it?
I was at CodeMash 3 or 4 years ago and saw a talk by Dustin Campbell, who's one of the project managers for Visual Studio, the project manager for the C# language tools. And so there's actually been ways that you could use Roslyn, I think going all the way back to Visual Studio 2012, it was but it was not as integrated. It was not nearly as integrated as now. And there's kind of been this documentation for a couple of years now that was kind of floating around. But all the old documentation is invalid. They actually went through some fairly major breaking changes.
So it's research.
Yeah.
Okay.
It was research, and I was rather fortunate to have encountered Dustin Campbell, who gave us some good tips.
How did you actually get CodeMash?
Same way everybody does. I sat there right when it was open. Actually, I for a while I was able to get in on the alumni ticket thing because I didn't go to the first two. I think I went to the third CodeMash, and then for a couple of years got in on the alumni. And then there was a year I couldn't go, and I had to take my chance. Other questions?
Have you ever tried what's called Xamarin?
Xamarin?
Versus Xamarin Studio versus Visual Studio?
And
And I know that you often Xamarin Studio is used for mobile apps. But Visual Studio, with that you develop like the Windows mobile app using that.
So one of the things that's interesting is that Miguel de Icaza, who's the architect behind Xamarin, who's the president of Xamarin Corporation, he said that they are going to continue to incorporate more and more of the open source technology that Microsoft has released. One of the things that I have been asked a couple of times that I generally don't answer is, could you go in and use the Roslyn compiler, but basically work with the emit API to emit Android and iOS executables? I simply don't know the answer to that.
Isn't that how dual code is doing Java, C# and JavaScript?
Something like that. I don't know for sure. Something like that. So, I mean, that's Xamarin. They do have their own compiler right now because they have a totally different emit process than CSC.exe or Roslyn does. But in the future, they might incorporate more and more of Roslyn. Does that answer your question?
Okay, yeah, and I think I saw Visual Studio after install them. But I'm not sure what version of Visual Studio. I think it's on 14.
No, well, it'd be 13 or 15.
13. So I don't know when 15 came out.
Visual Studio 2015 comes out like in 2 weeks.
Oh, okay.
Right now, when I was demoing it, it was actually the release candidate, which is hopefully why it wasn't working.
Hopefully not why it wasn't working, if that's the release candidate.
I'd rather think it was the release candidate than my code.
Well, sure, but for the rest of us, we're gonna end up.
Some questions asked.
Here comes update 1.
Did you ever use anything Microsoft until the first certified version?
I think that's about everybody.
Yeah, how hard do you think it'd be to add AOP?
That's
Aspect
another,
oriented programming.
so that's
Python style.
Yeah, so, something I've heard this question asked several times, is how does this affect PostSharp? Right, because PostSharp is the primary aspect-oriented programming library out there. If you're not familiar with what PostSharp does, it allows you to add some attributes to methods. They'll actually add things to the method, right? So you can have an attribute that says log, and it would log every time it's called, and you don't have to put that logging line in the attribute aspect. And the way that PostSharp works right now is that the compiler runs, and then PostSharp opens up the assembly, so either the DLL file or the exe file, and edits the IL directly. Which the fact that they ever got that to work is kind of amazing.
Yeah, they call it IL weaving.
Yeah, IL
It's very
weaving.
impressive.
Yeah.
I've never known those.
It's
So-
also really expensive.
What I don't know, I don't know anyone that works on that team or works for that company. You could imagine that you could use the emit API to do things like that, which, I mean, they've got to be having those conversations because, like Rob said, it's expensive, and is someone going to come out with a, product that does the same thing for the price? I don't know.
That's immediately what I thought when I saw this.
So, I've not tried to do, I have actually never tried to use the emit API, so I don't know how hard it is. It seems like that should be possible.
Yeah. That's some Python style AOP. I really like how they do that.
I've never seen Python.
It's pretty cool. They just do an @ sign and then whatever the function is, and then they have like it's kind of like interfaces where then in that you basically say call the body and then pass the argument, and then you can just wrap it however you want. And PostSharp is a little more funky, but still impressive how they did it.
Yeah, for sure. The fact that it was a third-party add-on to a language is darn impressive. Any other questions? All right, well, I'll hang around afterwards if anyone wants to see anything else.